Hello, welcome. I'm Andrew Choi. This is my presentation for Complex 529 Assignment 3 Paper 2. The paper going to introduce is an evolution of open source serverless computing framework support at the edge, written by Andrei, Palade, Aqeel Kazmi, and Siobhán Clarke, published in 2019 IEEE World Congress on Services. What's the problem? The success of cloud services and the rapid expansion of the IoT Internet of Things horizontally explode the data towards the edge of the network. The serverless computing implementation at the state-of-the-art deployment environment, which achieved by ephemeral containers. It only deploys when the service has been called and provides a small function for the transitory moment. Its function as a service FaaS deployment enable an on-demand basis for the services. The open source FaaS allowed a developer to deploy the FaaS container on their hardware, which to avoid the major cloud service provider a lock on their unique solution. The current study will evaluate the selected open source serverless solution on the traditional deployment environment. The author therefore select the prevalent open source serverless frameworks, Kubernetes, Apache OpenWhisk, OpenFaaS, and Knative, and set up the edge computing environments for deployment and to observe the performance under different loading pressure at the purpose of this paper. Why it is still a problem? The IoT devices are widely used in different scenarios and foresee that to be increased shortly. For instance, the emergency message prompting in the smartwatch or smartphone that to reach users' attention when detecting a major disaster. Another example like reporting the biological condition monitoring from the patient when using the smart devices. However, such scenarios are not feasible to process the data generated in the cloud because of the lag. It's locked in the vendor solution, the high latency, the privacy concern, and the mobility support. The serverless computing with its deployment highly reduced the high latency and the data protection, but its statement is lack of academic experimental support. But the related work. The benefit of serverless computing has been highlighted by Bodimi in the paper of serverless computing current trend and open problems. It mentioned that serverless computing eliminates the workload on managing servers and focusing on business logic. The major base referenced by the author is the paper written by Mohanty, who published a paper in 2018 that evaluates the open source framework in terms of Kubernetes, OpenFaaS, Fission, and Apache OpenWhisk. Mohanty mentioned a method to set up the serverless computing deployment with Kubernetes container deployment in the traditional way to generate the request. Several papers discuss the serverless computing using the edge environment as well as identifying the future challenge of auto-scaling. Nastic et al. Also investigating the real-time data analytic platform with a serverless solution at the edge. The author selected the stronger community as one of the important criteria of the open source framework. They first select the popular framework of the number of contributors in GitHub, further select the highest for experiment. The four open source frameworks are Kubernetes, Apache OpenWhisk, OpenFaaS, and Knative. All the frameworks are deployed in the same environment. At first, the architecture was separated into two layers, an edge computing layers and an IoT device layers, in which the edge computing layers consists of two sublayers. The underneath layer is the physical machine layers. All computer needs that layer for computation. There were two desktop machines, DM, with different CPU but equipped with the same RAM and OS. Apart from the physical layer, the virtualization layer install Kubernetes as container manager and to manage the container in which the DM1 work as a master node and the DM2 work as a worker node. Since the purpose of this paper is to test the serverless computing interacting with the IoT services, the IoT devices layer had been set up for 4 Raspberry Pi to mimic the IoT devices. 2 Raspberry Pi 2 Model B version 1.1 and 2 Raspberry Pi 3B version 1.2. All the IoT devices were sending multiple HTTP requests to the worker node and master node. The author analyzed the results through the qualitative metrics and the quantitative metrics such as the response time, throughput, and success rate. With the standard metrics, the author generated different load concurrency load pattern for testing in 1, 5, 10, 20 concurrent request generating. How it's different? The paper presents a different experiments from the deployment of IoT application using IoT infrastructure at the edge, as no similar experience was published before. The existing tendency is to deploy the IoT application in the cloud environment in which it sacrifices the performance of latency to achieve the serverless architecture. Previous research showed no resource-constrained edge environment when testing the serverless framework. This paper mimics the IoT and edge deployment without cloud utilization, therefore provide a future development in IoT device with serverless application. How did they evaluate it? Throughout the environment setup, the author generated multiple test cases with JMeter and created a Node.js function that was installed in each framework to receive the HTTP request sent by the JMeter. As mentioned before, the paper evaluated the quantified value in terms of mean response time, throughput success rate across 4 open source frameworks with 1, 5, 10, 15, 20 services per device. Also, they set up 50% CPU utilization as metrics for the auto-scaling basis. So the K8s HPA will automatically create a new pod to cope with the request. All the quantitative results have been generated to bar chart for measuring purposes. For the generated result, the Kubernetes has the overall performance, whereas the Apache OpenWhisk had not performed as same as the other solution. For example, the Kubernetes performed the best in response time, from 1 service to 20 services, with the range from 12.57 to 13.79 milliseconds. Look at the Apache OpenWhisk. In the figure of success rate, is perform worse when the service number increase. For the critic part, the section of selecting the open source frameworks, I was confused that the basis that the author had, which is the number of contributor and follower of the source code repository of the accordingly frameworks. Therefore, they picked the top 4 as the testing object for this paper. Look deeper into the priority and consider the related work from Mohanty. One major difference is testing object. Mohanty research did include Fission as the testing object instead of Knative. However, from the table 1 provided, it is observed that the number of contributors is equal to Kubernetes, yet the number of star was less than the letter. It is solid evidence that the author set out a cut-off line at fourth and omits the fiction in the research. My only critique is that if the author exceptionally include the fiction for our record purposes, which will provide more useful information and comparison to the industry. This is my presentation for paper 2. Thank you.